So in this video we are going to understand the linked list data structure, okay, and one of the most popular data structures out there in DSA. All right, so what is a linked list? So it is basically a linear data structure where elements are linked to each other using pointers. Okay, so each and every element in a linked list is called as a node. Okay, so for example, if I just show you this, so this is one particular element is called as a node. Okay, so a node itself has two main components, that is the data and a pointer. Okay, so in each node we have two blocks, right? One that holds the data or the value, and another one is the one that points to another block in the same linked list. All right, so as I told, there are two parts. One is data and a pointer. Okay, so unlike arrays, linked lists are stored in arbitrary memory locations, whereas arrays are stored in contiguous memory locations. So what do I mean by that? When we define an array, the memory location itself is defined where will it actually be stored. Okay, so it will be stored in contiguous memory locations, whereas linked lists are stored in arbitrary memory locations, which means that the nodes or the elements are scattered in memory. Okay, so there is no specific location, like whereas when you define in arrays, so elements in the array will be predefined. So the most common operations that we perform on a linked list is insertion, deletion, traversal and search. Okay, like we want to insert a node either, or we want to delete a node, either we want to traverse a node to get to the particular node, or we want to search something within our linked list. Okay, so the main benefit of using a linked list is that we do not have to unshift by, if we want to like insert or delete an item within a linked list, we just need to change the pointer. Okay, so we don't have to unlike arrays, when we remove an element from an array, all the other elements must relocate to the memory location that was left out. Okay, so it has to go back one step. Each and every element within an array should go back one step. So here the main benefit is we just need to change the pointer. Let's say I want to remove this node, so I just remove this and change this pointer. Instead of pointing here, it has to point to the next node. Okay, so we do not have to make the reshift between the different elements within a linked list. Okay, so if we consider this example, so this is an example of a linked list where the first node, okay, in a linked list is called as the head. Okay, and always the last node within the linked list is called as a tail. Okay, which will point to null, and here within the head nothing will point to the head. Okay, so this is as I told you, a simple linked list, and the only limitation of using this is, let's say we want to get an element or a node within a linked list, so we have to traverse the whole linked list from the start. Okay, whereas in arrays, since they are stored in contiguous memory locations, we just need to specify the index and we retrieve the value at that particular index. Okay, so the complexity of that is O of 1, but here to get an element, so here the time complexity is O of n. Okay, so that is a main trade-offs between arrays and linked lists. So this is an example of a singly linked list. Okay, so what is a doubly linked list? So doubly linked list is bidirectional. Okay, so since one node is pointing to the other node, the same way the other node will also point to the same node. Okay, so there is no head or tail in doubly linked list. So again, this same pointer which is pointing to other one will again be pointing to the same node. Okay, so we can go either directions. Okay, either forward direction or reverse direction. Okay, and also there is something called circular linked list. Okay, where again there is no head or the tail, again the value here which is pointing to the null. Okay, so which means that there is no data after that, so the same arrow will be pointed to the head of the linked list. Okay, so this will just keep going on circularly. Okay, so we have to implement this based on the requirement of our particular problem. All right, so let us now go ahead and implement a linked list inside JavaScript. So let us get started by creating a node inside a linked list. So I'm going to put that inside a class called node, and this contains two properties. As I told, one contains the data and another one is a pointer. Okay, so for the pointer we can call that as next. Okay, so inside this, let's define the constructor, and inside the constructor we are just going to pass in the data. Okay, so we set this dot data to data, and then we set this dot next. Okay, so by default it is going to be null. Okay, so this is the pointer which we called it as next, and by default it is going to be null. Okay, so this is our node class, so we can instantiate this class wherever we want to create a new node and all that. Okay, So let's now create a class called linked list, and inside this class we are going to write the constructor, and this constructor contains two values. One is the head of the linked list and one is the tail of the linked list. So let's initialize both of them. So initially this is going to be null and this dot tail as well. Okay, so this is a empty linked list when we instantiate the class. So now we need to add on methods to add insert and all of that. Okay, so when we want to add an element to a linked list, so first step is to check if the linked list is empty. Okay, so if the linked list is empty, we create a node by taking the value and consider that as the head of the linked list. Okay, so here we have an empty linked list. Let's say we want to add an element, so we just create a node. Okay, so this is a node. So we place the value over here, okay, whatever may be the value of data type, and this will be the pointer. Okay, so here this itself is going to be the head. Okay, so which doesn't point to anywhere. By default it is going to point at null. Okay, so this is the case for an empty linked list. Let's say we want to add an element to the linked list. So in this example the head is also the tail itself. Okay, let's say we have another node inside our linked list by the some value, and also this is pointing to null. Okay, so let's say we want to add another element to this, so this becomes the tail, by the way. Okay, so this is a new element that we are going to add. So this whatever the value we pass in, so the tail which was pointing to null, so now we need to point it to the new node that we are adding. Okay, so and this is not going to be the tail, but this is going to be the tail. Okay, where the pointer points to null. So this is how you can add an element to the end of the linked list. So let's create a method to add an element to the linked list. Okay, at the end of the linked list. So let's take in the data, and within this add we need to create a new node, right? So let us create a node. All right, so then we check if the linked list is empty. If the linked list is empty, then we need to set the current node as the head of that. Okay, so let's put an if this dot head is equal to null, or we can use a not operator, and then we just need to point this dot head to the current node. Okay, so this is we created a new node and we just pointed this head to this node instance. Okay, so the head of the linked list is now pointing at the node that we just created here. Okay, and we just need to pass in the value of the tail as well. Okay, so and of course we need to pass in data here. All right, so if there is some elements in the linked list, so we already have an head, which means, so let's handle that in the else case. So we just need to point the tail of the linked list, which is by default null. Okay, and point that to the node that we created. So this dot tail is equal to the node. Okay, so sorry, this dot tail dot next. Okay, and because the tail itself already existing, we just need to point the tail of that to the new node that we created. So like this, and yeah, so after we do this, so finally we just need to set this dot tail to node. This dot tail is equal to node. So what we are doing here is the previous node, which the tail was null, we are pointing that next value to the current node that we created. So now this is no more the tail, so the new node is now the tail. So either it is the head or the tail, so this value should always be there. Okay, so so if there is no head, okay, so this is also going to be the tail. Okay, so now this is done. So let's now create a linked list. So I'm just going to call this linked list and initialize a linked list. All right, so now we just need to pass in a value, create a node by calling the add method. So linked list dot add, and let's say we add the value of 100. Okay, so once I do this and console log linked list, all right, and try to run this file, so you see that we get a linked list instance where the head and the tail is pointing to the same node. Okay, where the data is 100 and the next value is null. Okay, so yeah, let's try to add in another element. Let's say 200, and now you see that the head of the node is the data having 100, and the next value is pointing to this node, okay, which is having the data 200. Okay, so you see the next value is pointing to this, and this node is the next value of this is pointing to null. Okay, so I hope that made sense. So again, if you keep doing this multiple times, so we keep chaining across. Okay, so you see that the first one, which was 100, it is now pointing to 200, and this 200 is pointing to 300, and then the next value of 300 is pointing to null. Okay, so now let us see how can we get an element from a linked list. Okay, so let us consider this example over here. So let's say I want to get an element over here. Okay, so in linked list we do not have any kind of indexes, unlike arrays. Okay, so we presumably create some indexes. Okay, so let's say this is at the 0th index, this is the first index, second index, and this is the last index, that is third. So let's say we want to get what is there at the second index. Okay, so we keep an counter, let's say count I is equal to 0. So now we just need to traverse. Okay, unlike arrays, we just specify the index number and just get whatever the values are there. So here we just need to traverse towards the link throughout the linked list, and then find when we get at the index 2. Okay, so we this is the current, let's say current node, and then we just keep on traversing. Okay, so we see what is the next node, and then increment I. Okay, so the next node is this, so we increment I. So this is going to be I at 1, and then we see until we specify the index, okay, that we pass in as arguments. Okay, so let's say this is the second index, so I becomes the target index, so we get the value whatever is there within this particular node. Okay, so this is how you can get a value from a linked list. So let's now create a method to get a value from the linked list. So let's create a method called get, and remember we need to pass in the index. All right, and now as I told, we just need to traverse throughout our linked list until we find the index that is passed in. So let's set a variable called current, and let's set that to this dot head, which is initially okay, so this is the current node. Okay, so as we keep traversing across, so now we just need to initialize a counter. So let's say I equals 0, and now we just need to run a while loop, so until we match the current index. So while I is less than the index that is passed in, and now we just need to traverse. So how do we traverse? We take the current, this is actually a node, right? So when you hover on this, it shows us the type called node. So this has a property called next. Okay, so we just need to keep on finding unless the next value is there. Okay, so let's say current equals current dot next. Okay, so when we set this to current dot next, we are now going to the next node. Okay, so the next node itself, again, it's a node. Okay, so it's a chain. So let's again increment I. Okay, so this will run a loop, and unless the I matches the current index. So once it matches, we return the data of that. Okay, so return the current dot data. All right, so once we save this and just try to get a value from the linked list, so linked list dot get, and let's say we want to get at the first index, so we should be getting 200. So when we go back to our terminal, so I need to console log. Okay, so you see that we get 200. Okay, so if I just say get at the second index, we get 300. All right, so that's looking good. So now we want to add an element to a linked list. Okay, but not at the end of the linked list, but in the between. Okay, by specifying an index. Okay, so we specify the index and the value that we need to insert inside a linked list. Let's say I want to insert at node 2. Okay, so what we just need to now do is, again, we need to traverse throughout the linked list, keep this is the current node, and then set a variable, let's say I is equal to 0, and then we keep on traversing and update the I value. Let's say once we reach at node 2, where we have to create the new node. So let us create that node. Okay, so this is that node, and this is going to be the value. Okay, and this is going to be the pointer. Okay, so all we now need to do is we just need to play around with the pointers. Okay, so now the one which was pointing at index 2, we just need to point that to the new node that we actually created. Okay, so we can just point this to the new node, and this new node, the pointer should point to the next element within the linked list. Okay, so this becomes the third index, and this doesn't matter. Okay, so this is just, we are considering these indexes. So then we rename this to 4. Okay, so there are 4 nodes within our linked list, and this becomes the second index. Okay, so this is how you can insert a node within a linked list. Okay, so by a particular index. So now let's create a method to insert an element at a index. Okay, so we can just call this index, let's call this insert at. Okay, and then pass in the 2 values, one is the index and then the data. Okay, so inside this method we again need to traverse across the node. So again we need to do the same thing. So let's first check if the index which is passed is 0. Okay, so when we pass the index as 0, then we are saying that we just need to set the node to the as the head of the linked list. Okay, so let's check if the index is equal to 0. So we just need to first create a new node. Okay, so just as we did over here, and set this to new node. Okay, and now we just need to set the next property of this node to the head of that. Okay, and now this node becomes the head. Okay, so we say node dot next equals this dot head. Alright, so now we need to set the head of the linked list to this particular node, okay, that we just created. So we say this dot head and set that to node. Okay, so I know this is kind of confusing initially when I started learning linked list, so this was even confusing to me. So I'll just make it clear. So the new node that we just created, we pointed the next value of that to the current head. Okay, so this is not the new head, this is the previous head. So now we are setting the new head of the linked list to this current node. Okay, so I hope that made sense. So if there's anything, if you're finding confusing, so you can just Google it and just try to understand this. Okay, so let's put the else block, and again now we just need to traverse. Okay, so we can just copy this piece of code here, and once we have initialized the current, so apart from the current and the index, so we need to have the previous node of the current iteration. Okay, so because we need to point the previous pointer to the new node that we created, right? So let us set previous, and initially is going to be null. Okay, and then we now need to run a while loop. Okay, so while we find the index, so index while I is less than index, and inside this first we set the previous value to the current value. Okay, and now we need to update the current value to this next node. Okay, so current equals current dot next. All right, and we increment I. So what we are now doing is we already set the current value to the previous one. So now we are updating the current value itself. Okay, so we have the previous value and also the current value, and we increment the index. So once we find the index, so we create a new node. So let's create that. So once we create a new node, we just need to pass in the data, and also I need to pass in data here as well, which I forgot. And once we created a node instance, so we need to point the next value of that node to the current value. Okay, since we are inserting at the index that is provided, so let us point node dot next and set that equal to current. Okay, so the current iteration, and the previous one, the previous next, we need to point at this new node that we created. Okay, so previous dot next, and set that to the new node that we created. All right, so I hope that made sense. And now let's test this out if we are able to add an element to the particular index. So let's say I want to add an element to index number 2, let's say. So I can just delete this and say linked list dot insert at, and we insert at the second index and pass in the data of, let's say 250. Okay, so it should somewhere come between this and this, and once I save this and open my console, so there we should be able to see that okay, so something's wrong, sorry, nothing was wrong. So inside our terminal, so when it has a lot of values, so it just gives us the generic the type of the instance that we create. Okay, so now if I just try to get at the index 2, so let's say linked list dot get at the index 2, so we should be able to get 250. Okay, so actually I need to console log this. Alright, so you see that we get the value of 250, okay, at the second index that we inserted. Okay, so since terminal doesn't allow for more values, so that's why we have to do this. So okay, anyways, it's verified. So let us now create another method to remove an element from the linked list. So let us now understand how can we remove an element from a linked list. Okay, so to remove an element, we need to specify the index where we need to remove the element. So again, we just need to implement the traversing technique. So we set the current node over here, and then we just need to keep on traversing by setting a, like, let's say a variable. So initially it's going to be at the 0th index. As we keep on traversing, the index keeps getting updated. So once we find the index to be deleted, like here we just need to again arrange the pointers. Okay, so this pointer which was pointing at index 2, we just need to point that to index 3. Okay, so this 2 will not be existing anymore. Okay, so we can just remove this node, and we can just point the pointer of index 1 to pointer of index 3. Okay, like this. Okay, so the 2 index will no longer exist. Okay, so very simple. And the best part is, again, we don't have to do the reshifting thing unlike we do it in arrays. Okay, and this becomes index 2. All right, so this is how you can remove an element from a linked list. So let's call the method as remove from. Okay, and pass in the index. Okay, so we need to remove at that particular index. Okay, so let's check the index if it is equal to 0, which means that we want to remove the head. Okay, so all we just need to do is just point the head to the next element of the node. Okay, so let's check if index is equal to 0. Okay, so what we just need to do is this dot head. So we set the head of the linked list to the next node. Okay, so that is this dot head dot next. All right, so let's say there are 2 linked lists. Okay, so we are pointing that to the next node's head. Okay, so that is what we are actually doing. So let's put an else here if the index is not 0. So again, we just need to traverse across and find the index where we actually need to delete from that linked list. So let's again do the same. We can just copy paste from here. So we have initialized 3 variables, the current, previous, and the I. Okay, so now we run a while loop till we find the index. Okay, so now we just need to again do the same thing. So we just need to set the previous to the current and change the value of the current to the next node. So current equals current dot next. Okay, and increment I. Okay, so till we find our index. So what we just need to now do is set the previous dot next to the current dot next. Okay, so the previous node which has a pointer, so we are pointing that to the current node which is the which is having a next to of that. Okay, so the current itself is deleted, so we are pointing that to the next node. Okay, so that is how we can remove an element from the linked list. So let's test this out. So we can try to remove at the index, let's say 1, and try to run this. So you see the node at index 1 which has a value of 200 is not there within our linked list. Okay, so the 100 is pointing to 300. So yeah, that's it. And now we can create a method to print all the values within our linked list. So now we want to print all the values within our linked list. Okay, so again we use the traversing technique. Again we set the current value to the first node, and then for each node, while like we run a while loop, right, until we reach the end of the linked list, we just keep on printing the values, as simple as that. So once we keep on traversing, we put a console log there, like within a while loop, and we keep on going until we reach the tail of the linked list. Okay, so let's implement this. So let us create a method to print all the values. Let's call this print all, and within this we just need to again traverse across and console log at every iteration we make. Okay, so let's say current equals this dot head. So we are starting from the head and going all across till we reach the tail. Okay, so let's say while current is not equal to null, okay, which means that we have reached at the end of the linked list, and all we just need to do is console log the current node is data. Okay, so current node dot data, and now we just need to increment the current. Okay, so set the current value to the next node. So current equals current dot next. All right, so that's done. Let's now print our linked list. So linked list dot print all. So we see that we are printing all the values. Okay, so we have only 100 and 300 since we are removing at the index 1. So if I just delete this and try to rerun the file, so we get 100, 200, 300. Okay, so these are the three elements that we are adding inside our linked list. So we are printing all of the values, and yeah, so this is all about linked list, guys. So I know this is kind of little bit confusing, so just keep practicing more and more until you fully understand. And if you don't understand, just put console logs and just try to check what is the state of the particular value, so that if you find anywhere stuck in between. So that's what how actually I learned. So it took me a lot of time to understand this concept of linked list. Okay, so yeah, that's it for this video, guys. So thank you so much for watching. If you have any questions, please let me know in the comments. So I'll see you guys in the next video.